Welcome to this comprehensive guide on Internet service providers and bandwidth. In this video, you will learn about the fundamental concepts that power your Internet connection, how ISPs deliver services to millions of users worldwide, and what bandwidth really means for your online experience. Whether you are a student, professional, or simply curious about how the Internet works, this series will break down these essential concepts in an easy-to-understand way. An ISP, or Internet Service Provider, is a company that provides Internet access to individuals and organizations. ISPs are the backbone of Internet connectivity. They own and maintain the infrastructure like cables, servers, and routers that physically connect your device to the World Wide Web. Think of an ISP as a utility company, similar to electricity or water providers. Just like water companies manage pipes to deliver water to your home, ISPs manage networks to deliver Internet to yours. Some well-known examples include AT&T, Verizon, Comcast, and Google Fiber, though many local providers also exist in various regions. ISPs use different technologies to deliver Internet to your home or office. Let's explore the main types. First, there is DSL, which uses your existing telephone lines to transmit Internet data. Next is cable, which uses the same coaxial cables used for cable television. Then there is fiber-optic technology, which transmits data using light signals through glass fibers and offers the fastest speeds available. Finally, satellite Internet sends and receives signals from satellites orbiting Earth, making it useful for remote areas where other types of infrastructure are not available. Each type has different speed capabilities and availability depending on where you live. Bandwidth is the maximum capacity of data that can transfer over your Internet connection in a given time period. To help you understand this concept, imagine a water pipe. The wider the pipe, the more water flows through it at once. Similarly, the higher your bandwidth, the more data flows to and from your device simultaneously. Bandwidth is measured in units called bits per second. You will commonly see these abbreviated as kbps for kilobits per second, Mbps for megabits per second, and Gbps for gigabits per second. The larger the number before these units, the greater your bandwidth capacity. Many people confuse bandwidth with speed, but they are different concepts. Bandwidth refers to the total capacity or the width of the pipe, representing how much data can transfer at once. Speed, on the other hand, refers to how fast that data travels through the pipe. Think of it this way. If bandwidth is the width of a highway, then speed is how fast cars drive on that highway. ISPs offer different bandwidth packages to their customers. A higher bandwidth package typically means faster, smoother Internet connections, fewer interruptions, and the ability to handle multiple activities simultaneously without slowdowns. ISPs use different pricing strategies to sell their services. First, there is the flat rate model, where you pay a fixed monthly fee for unlimited or capped data each month. Second is tiered pricing, which offers different speed and data limit packages at various price points, allowing customers to choose packages that fit their needs. Third is pay-as-you-go pricing, where charges are based on your actual data usage each month. Finally, there is contract-based pricing, where customers receive discounted rates in exchange for committing to a longer service agreement. Understanding these models helps you choose the right plan for your budget and usage patterns. Several factors influence how much you pay for bandwidth. Speed requirements matter significantly, as higher bandwidth speeds cost more than lower speeds. Your geographic location also affects pricing, because rural and remote areas typically have higher costs due to the challenges and expenses of building Internet infrastructure in those regions. Data limits also impact pricing, with unlimited data plans costing more than plans with capped or metered data. Finally, the size of the ISP provider influences pricing. Large, established ISPs can offer better rates because they benefit from economies of scale, allowing them to spread their infrastructure costs across millions of customers. To make the most of your bandwidth and reduce costs, you can employ several optimization strategies. Data compression reduces file sizes before transfer, which decreases overall bandwidth consumption. Caching stores frequently access data locally, minimizing the need to repeatedly download the same information. Content delivery networks, or CDNs, distribute content globally to reduce the load on any single server. Load balancing spreads traffic across multiple connections and servers, ensuring no single connection becomes overwhelmed. These techniques help ensure efficient use of available bandwidth and can improve your overall internet experience. Network professionals use advanced techniques to manage bandwidth more effectively. Quality of service, or QoS, prioritizes certain types of traffic to ensure critical applications receive the bandwidth they need. Traffic shaping controls the flow of data to prevent network congestion during peak hours when many users are online. Deduplication eliminates redundant copies of data, reducing the overall volume that needs to be transferred. Usage monitoring analyzes patterns to identify inefficiencies and optimize how bandwidth is allocated. These advanced techniques are commonly used by ISPs and large organizations to maintain reliable service for all users. To maintain healthy network performance, follow these best practices for bandwidth management. First, monitor your usage continuously to track real-time bandwidth consumption and identify bottlenecks early. Second, establish clear quality of service rules that prioritize critical traffic over less important activities. Third, perform regular capacity planning by forecasting future bandwidth needs based on growth trends and usage patterns. Finally, conduct regular maintenance by updating firmware, auditing hardware, and optimizing network configurations. These practices help ensure reliable service, prevent unexpected slowdowns, and keep your network operating at peak efficiency for both personal and professional use.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.